Hello everyone, and welcome to this video on the Python programming language. So in this video I will attempt to use the Stochastic Relative Strength Index indicator, which is just an indicator that uses both the stochastic indicator and the RSI indicator, and I'm going to use this to determine if an asset like Apple's stock is overbought or oversold. Now before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. And the material in this video is purely educational and should not be taken as professional investment advice, as I am not a professional advisor, so please do your own research before making any sort of investment. Now I'm currently on Google's website called colab.research.google.com, and this is where I will be writing the code. So if you're going to be writing the code with me, go ahead and click on File, then click on New Notebook, where a new tab will open up for you, and then eventually a new cell. And in this cell, I'm going to put in a short description about the program. It might not be that short actually. So we're going to do that in comments. So I'm just going to type description, and I'm going to put this program uses the stochastic relative strength index, or also known as stock RSI indicator, and Python to determine if an asset is overbought or oversold. Okay, and then I'm going to create a new cell by clicking this code button here in the top left, and in this cell I'm going to import the libraries that I plan on using throughout the program. So I'm going to import numpy as np, I'm going to import pandas as pd, and I'm going to import matplot live.pyplot as plt, and then I'm going to run this program by clicking that button here to the left, and this will let me know if I made any mistakes. And it looks like we're good, so I'm going to create a new cell, and now in this cell I plan on loading the data. So let's load the data, and so I'm going to load information on Apple stock. So to do that I need to use Google's library. So I'm just going to type from google.colab import files, and then type files dot upload. Alright, and let's go ahead and run this and click on choose files. I'm going to choose this aapl.csv file, and it's done, it's uploaded already. So I'm going to create a new cell, and next I'm going to read the file. So I'm going to create a variable called df and set it equal to pd.read_csv, and put in the name of the file, which is aapl.csv, and then I want to show the data. So I'm just going to type df here, and let's go ahead and run that. And now we can see that this data set contains 188 rows of data and 7 columns, and those 7 columns are date, open price, high price, low price, close price, and adjusted close price, and volume. Alright, and the index are all integer values, or the indices are all integer values, so I'm going to change that to be the date. So I'm just going to set the date as the index, and to do that just set df equal to df dot set underscore index, and then I'm going to input pd dot date time index, and here I'm going to put in the date dot values. Alright, so I'm going to run this again, and now we get those indices to be the date instead of integer values. Alright, so let's go ahead and create a new cell, and now in this cell I'm going to create a indicator called the exponential moving average, and I'm going to use a function to do this. So here I'm just going to create a exponential moving average indicator function. Okay, alright, so let's just create that function. I'm going to call it EMA, and this function will take in some data, and then it will take in some time period. So I'm going to set the time period equal to 20, because Typical time periods for moving averages are 15, 20, and 30. So I'm just going to default it to be 20. It's going to take in some column. I'm going to default that column to be the close price. Okay, and then it's just going to return the data at that column dot EWM, and I'm going to set the span equal to period and set adjust equal to false, and then I want the average, so I'm going to type dot mean here. Okay, so let me go ahead and run that, and we're going to use this later on to calculate the stochastic RSI, or the stochastic relative strength index. So let's create a new cell, and now let's go ahead and create a function to calculate the relative, or the stochastic relative strength index. Okay, and it looks like I misspelled strength here. Okay, so let's call this function stock RSI. It's going to take in some data. It's going to take in some time period that I'm going to default to be, I go with 14 for now. And then I will set the column equal to the close price column. All right. So the first thing that we need to do is calculate the RSI. And before we can do that, we need to calculate some other things. So let's create a variable called delta, and let's set it equal to our data at that column, and then type .diff here and input the value 1. So this function is going to find the discrete difference over the column axis with the period value equal to 1. Okay, and then I want to drop any NAs, so I'm going to set delta equal to delta dot drop NA, so we can remove those missing values. And then I'm going to create a variable called up, and I'm going to set this equal to delta dot copy. So I'm just going to copy delta into up, and I'm going to create a new variable called down, and I'm going to make a copy of delta as well. So I'm going to type delta dot copy again for down. All right, then I want to set all of the values in up that are less than 0 to 0. So I'm just going to type up, and I want all the values in up that are less than 0, I want to set them equal to 0. And then for down, I want to set all the values in down that are greater than 0 equal to 0. So I'm just going to put down greater than 0 equals 0. All right, and then I'm going to store these values that are in up and in down. I'm going to create some new columns, and I'm going to store those values in those new columns in our data set. So I'm going to create a new column called up in data, and I'm going to set it equal to up, and then I'm going to create a new column called down in our data set, and I'm going to set it equal to down. All right, so now I've stored those values in new columns called up and down. All right, so next I want to get the average gain. So I'm going to create a variable called avg underscore gain, and that's of course short for average gain. And I'm going to set this equal to our EMA function, and our EMA function is going to take in some data. It's going to take in the time period from our function here, and then the column will be equal to the up column in our data set now that we just created. And then I want to get the average loss, so I'm going to create a variable called avg underscore loss, and I'm going to set this equal to the absolute value of our EMA so that we don't get any negative values, right? So this will take in our data, and it will take in the time period, and then the column that this will use will be that down column that we just created. All right, now with the average gain and the average loss, we can calculate the relative strength, or RS. So I'm going to create a variable called RS, and I'm going to set this equal to our average gain divided by the average loss. All right, and that gives us our relative strength. So with the relative strength, we can calculate the relative strength index, or RSI. So I'm going to create a variable called RSI, and I'm going to set this equal to 100.0 minus 100.0 divided by 1.0 plus RS. And now we have calculated the relative strength index. So with that information, we can calculate the stochastic RSI, or the stochastic relative strength index. So I'm going to create a variable called stoch RSI, and I'm going to set this equal to RSI minus RSI dot rolling, and it's going to put in, we're going to put in that time period there, and I want the minimum value there, so we're going to type dot min, and we're going to divide this by the relative strength index dot rolling period, where I get the maximum value. So dot max here. Let me just bring this up a little bit. There we go. And let's see, I need to subtract that with the RSI dot rolling period dot min. Okay, and that's the formula for the stochastic RSI. And let me just double check that everything is good. All of the parentheses are where they need to be. Okay, so all right, so I think that looks pretty good, and let's return the stoch RSI. All right, so if I did everything correctly, this function should work. Let's go ahead and run this cell, and let's create a new cell. And now in this cell, we're going to go ahead and store the stochastic RSI data in a new column, and I'm going to call this column stoch RSI, and I'm going to set this equal to the function that we just created called stoch RSI, and it's going to take in the data df, and that should really be it. So let's go ahead and run this. Okay, and let's create a new cell, and now in this cell I'm going to plot the data. So I'm going to plot the close price, and then I'm going to plot the stochastic RSI. So first I need to create a figure and a set of subplots. So I'm going to create a variable called fig and x1 and x2. So these will be my variables. I'm going to set them equal to plt dot subplots, and I'm going to give it a number, give it some number of rows. So n rows will be equal to 2, and then I want them to share the x-axis. So share x will be equal to true, and then I want to plot the close price. So I'm just going to type x1 dot plot, and then I'm going to use the indices, or the index, for the x-axis, and I'm going to use the close price for the y-axis, and then I'm going to give this a color. So I'm going to set the color equal to red for now, and then I'm going to plot the stochastic RSI. So I'm just going to put plot the stoch RSI. All right, so I'm going to set x2 dot plot. I'm going to put in df dot index and df stoch RSI column. Okay, and I'm going to set the color here to blue, and let's go ahead and give this a line style just to make it stand out a little more. We're going to put some dashes there, and I think that that's it. So let's go ahead and run this and let's see what it looks like. So there we go. It looks interesting. So let's make it look a little better. So I'm going to rotate the X ticks by 45 degrees. So just type lt.x ticks and then rotation equal 45, just like that. And I want to get rid of that gap, so I'm just going to type here. Let's see, we're going to remove the vertical gap between the subplots. So I'm just going to type plt dot sub plots underscore adjust, and then I'm going to set h space equal to 0.0, and then I want to give it some grid lines as well. So let's go ahead and do that. Let's set grid lines. So just type x1 dot grid and x2 dot grid. Okay, now let's go ahead and run this again. And it looks like I misspelled rotation here. So rotation. All right, so let's run that. All right, and now I think this looks a lot better. So what are we looking at here now that we've done all this work? So down here, this tells us if the stock is overbought or oversold. And you know what? Let's go ahead and put some lines as well to make it a little bit more obvious. So we're going to add one more thing to this plot. So let's plot the oversold, that's 0.2, and overbought, that's 0.8 lines. All right, so just type x2 dot xh line and then put 0.20, and the color will be equal to orange. And I'm going to just highlight this, and I'm going to copy, use Control C, and then come down here and paste it using Control V, and then change this to a 8, and let's run this. Okay, so now it looks really, really good, or at least looks better. So here we can see when this line here, when this data goes, or this RSI, the stock RSI data goes above 0.8, then we know that the stock is being oversold. I'm sorry, overbought. The stock is being overbought above 0.8. And when it goes below 0.2, then the stock is being oversold. So if the stock is being overbought above 0.8, this again may be a good time to sell. And when it goes below 0.2, that may be a good time to buy. All right, so let's take a look at the price of Apple during these time periods. So we can see for this time period right here where the RSI indicator, the stock RSI indicator, is telling us that the asset is indeed overbought. We can see that the price is pretty far up here, and it would have been a good time to sell. And then it looks like here it's telling us that that the stock was oversold, and as such this would be a good time to buy. And we can see that that seems to be the case here. It would have been a good time to buy there. All right, and we can basically see some of these same patterns throughout this graph. Now let's just take a look at another one like this drop here. This tells us it would have been a good time to buy, and indeed it would have been. So this is pretty cool. Right now, currently, it looks like the asset is neither overbought nor oversold, so it may just be a good time to keep your asset. But this looks pretty promising as an indicator. And again, I'm not a financial advisor, so please take this all with a grain of salt. Well, that's the end of the video. And if you want to start an investment portfolio of your own, you can click on the link below in the description and get 2 free stocks valued up to $150 on Webull when you deposit $100 or more. And don't forget to grab $10 worth of Bitcoin using the BlockFi link below. Also, when you deposit $100 or more, it's basically free money. Thanks for watching, and thank you to the supporters supporting this channel on patreon.com. If you would like to become a supporter on Patreon or just get the code, then I will leave a link in the description below. Again, thanks for watching, and I hope you all have a great day, and I will see you in the next video.